In this video, I would like to consider the problem of simplifying an expression like the one in this example. Simplify the square root of 18 times x to the 6th power times y to the 7th power, where the quantity under the square root has some variables in it. Now there are a number of different ways to approach this problem, and I'm just going to show you one of those ways, which I think is the simplest method to start with. And as we get further into chapter 9, several weeks from now, we will talk about alternate ways to simplify roots like this one. The first thing that I'm going to do is I'm going to focus on the constant multiple under the square root. I'm going to take a look at 18. I'm going to take 18 and I'm going to break it down into smaller factors. Now, when you are factoring a number like 18, the first thing that I ask myself is, can I think of any number which divides 18 evenly? Well, the first one that occurs to me is that 18 is an even number, and even numbers can be divided evenly by 2. So 18 can be split as 2 multiplied by, well, 2 goes into 18 9 times. So 18 can be thought of as 2 times 9. Now we can break this down even further because 9 is not a prime number. 9 can be broken down as 3 goes into 9 3 times. So looking at all these factors, 18 can be split up as 2 times 3 times 3. Okay, now having factored the constant multiple under the square root, let's rewrite the thing that we're trying to simplify. We have the square root of, now we know that 18 is equal to 2 times 3 times 3. Now we can also rewrite the quantity x to the 6th power. X to the 6th power is shorthand for 6 x's multiplied together. So 1, 2, 3, 4, 5, 6. And finally, we have 7 copies of y. So I'm going to write those down. 1, 2, 3, 4, 5, 6, 7. Turns out that giant square root bar still wasn't large enough. Now, when you are simplifying a square root, you're looking for pairs of common factors. For example, we have a pair of 3's. Now, anytime you see a pair of factors underneath a square root, that can be turned into a single copy of that factor outside of the root. So 3 times 3 inside the root becomes a single 3 outside of the root. We also have several pairs of x's. We have this pair of x's, a second pair of x's, a third pair of x's. In total, 1, 2, 3 pairs of x's. Which means that each of those pairs can be turned into a single x outside of the root. X times x times x. And finally, we can find several pairs of y's. This y can be paired with the second y, the third can be paired with the fourth, and the fifth can be paired with the sixth. So those 3 pairs of y's can be turned into 3 y's outside of the root. So, having gathered those pairs together and brought as much outside of the root as possible, let's see what is left behind. Well, we have this 2 in front, who could not find a partner, and we have this y in the back, who could not find a partner. And therefore 2y is left under the square root. Finally, to finish simplifying this, all we want to do is rewrite the final answer using exponents. So instead of x times x times x, this can be rewritten more compactly as x cubed. And instead of y times y times y, this can be rewritten as y cubed. And finally, we have the remaining. Multiply that by the square root of 2y, and this expression would be our final answer.